Alright, talking some very basic circle properties and some definitions here. First, we want to talk about a chord. A chord is any segment who has endpoints on the circle. One special chord we talked about many times before is just the diameter. The diameter goes the whole way across and has both endpoints on a circle. A secant line is another line. It's the full line that would cut through a circle, so it has to cut through 2 points. A tangent line is the same thing, just if that line only touched right at one point on the edge of a circle. And we talk about tangent lines a lot as we move forward through all levels of mathematics, all the way through AP Calculus in the end, and even beyond that if you took calculus or beyond in college. Now, some other things we want to look at are some special kinds of circles themselves. Congruent circles, congruent means the same. Congruent circles means I have two circles that are the exact same. If they are the exact same, I would put them right on top of each other, and they would actually be the same thing. Of course, it won't let me move them the way I'd like to. They would be the exact same circle. That makes them congruent. The main thing is same radius. Concentric circles, same center, so I can have different sizes, but as long as they still originate from this same center point right there, that's all that matters. And then tangent circles down here, these are not tangent as they are. Tangent would be if they meet just at one point, just like that. So they're meeting right at that point right there. That makes them a tangent circle. Okay, a few more basic properties to look at here. If we have two radii here, and then two tangent lines coming out that end up intersecting each other. First, radii are always congruent. The first property we're going to say is these segments must be congruent as well. So we have a big kite forming right here, a big quadrilateral shape here. Another thing, tangent lines, they must intersect at right angles. They always intersect with the radius at a right angle. And the last step here is that these two angles, we'll call this a central angle. We'll call this the exterior, well, not really an exterior angle, but the angle where the tangent lines meet. They must add up to be 180 degrees. And that should make sense because the whole kite itself should be 360 degrees. So to see how this works, we have an example right here. Angles B and D should be very basic right off the top, or B and C I should say. They must be 90 degrees because they're a radius intersecting with a tangent line. Angle D should be supplementary with angle A. So they should add to 180. That means angle D has to be 140. Now, BD is a radius, so it must be the same as the other radius. It must be 3 centimeters. The toughest one to find would be this last one. Well, BA is one of the tangent segments, same as CA. That means they must be equal to each other. 4x minus 10 must equal 2x plus 2. So that means if I subtract 2x from both sides and add 10 to both sides, I get 2x equals 12 or x equals 6. Now, that's not what BA is, that's just what x is. So I need to take that and plug it back in. 4 times 6 gives me 24. Take away 10 from that is going to give me 14 at the length, 14 centimeters at my length. So that's how you use some basic circle properties here with tangents especially to find some missing values.